Hi kids. Okay, brand new lesson, lesson 3. We're going to be talking about proportional relationships, okay? So here's the Dear Family picture, or Dear Family page. We aren't going to go through that, but if you'd like to read it, you may. Let's look at the fun little activity. Have you ever played a video game and found that a day in the game was shorter than a day in real life? The game designers might have decided that 20 minutes passing in a game for each minute that passes in real time. So for example, if 1 minute passes during real life, 20 minutes had gone by in the game. That would mean that the relationship between real time and a game is a proportional relationship. Where else do you see proportional relationships in the world around you? This one's kind of tricky. A proportional relationship in the video game, I think that's a really good example. Maybe a proportional relationship could be like our blueprints that we talked about. You know, if I had a blueprint of a building and then I was making the real building, the proportional relationship would be a scale factor, right? It would be to scale. So maybe a blueprint to the real life thing that they're making. So blueprints in the building. Okay. I talked about my little human shrink machine. I know that doesn't exist in real life, but it reminds me of this scene from Willy Wonka and the Chocolate Factory, the original, where Mike TV gets in front of that little shrink ray and then it sends his little atoms through space and then he uploads on the TV. But he's perfectly proportional, right? Like he still looks like a person. He doesn't look like he got shrunk down or flattened. He's still a person with the same proportions, it's just now he's small. So I know this is a really silly example, but I'm going to put Mike TV getting shrunken in Willy Wonka. Okay, I know that's funny. But if you guys can think of anything else, go ahead and write them down. If not, don't worry about it. Let's go ahead and start Lesson 3, Session 1. We're still going to be talking about proportional relationships, okay? So, let's go and get started. In 1 week, each cat at a shelter eats 7 cans of cat food. Okay? So, 1 week, we go through 7 cans of food. The ratio of cans of cat food to cats is 7-1. Okay? So, for every 1 cat, they go through 7 cans a week. For every 2 cats, they would go through 14 cans a week. Now, how did I know that? Well, I just doubled it, right? If I had 2 cats and I know 1 cat goes through 7, then I know that 2 would go through 14. How about 3? 21. Now, how did I do that? Basically, what I'm doing is I'm taking the number of cans and I'm multiplying it by the number of cats. So if I had 4 cats, I would take 7 times 4 and get 28. If I had 5 cats, I would take 7 times 5 and get 35. If I had 6 cats, I'd take 7 times 6 and get, go on your shoe, 42. And if I had 7 cats, it would be 7 times 7 is 49. And if I had 8 cats, it would be 7 times 8 is 56. Are all of the ratios in the table equivalent? Explain. Yes, they all have the same unit rate. The unit rate, remember unit rate means 1 of something. They all have the same unit rate of 1 to 7. Right here, 1 to 7. They all have the same unit rate, okay? So, are they proportional? Yes. Explain. They all have the same unit rate, not raid, of 1 to 7. Okay? 1 cat to 7 cans of food. I guess I could say 7 to 1. 1. That means 7 cans per 1 cat. What is the unit rate for cans of cat food per cat? We just did that. 7 to 1. 7 cans per 1 cat. Okay? Suppose you know how many cats are at the shelter in any week. Can you find the number of cans of cat food for X amount of cats? If I have an unknown amount of cats? In other words, if I know the unit rate, can I find any number for any cats? What if I just gave you some random number? What if I said, okay, there are 32 cats now at the shelter. I know that my unit rate said I can take 7 and multiply it by how many cats there were and get the number of cans. So if I take 32 times 7 and get 224, that means I need 224 cans to last 1 week. Okay? What if I said that there are 18 cats at the shelter? Then I'd do the same thing. Still take my unit rate, 18, and times it by 7. Okay? And that means I need 126 cans. So the question says, can you find the number of cans that the cats would eat no matter if you knew what number you had or not? Yeah, you would take X amount of cats and just multiply it by 7, right? So I'm going to say yes. And then this is literally my explanation. X cats cans times 7. That's my explanation. You take your cats, which is your number of cats, you times it by 7, and that's how you'll get your number of cans. E. When a group of ratios are equivalent, it means there is a proportional relationship. Yay! Proportional relationship. So if our ratios are equivalent, they have something in common, that is great. That means it's proportional. At the shelter, is there a proportional relationship between the number of cats and the number of cans of food? Explain. The number of cats and the number of cans. If you look up at the chart at the top, do you notice something? If I take the number of cans, say 7, and I divide it by the number of cats, let's say 1, it'll equal 7. Let's try it for any of those. What happens if I have 5 cats, and I know that would be 35 cans. Whoops, I'm going to write that other way around. 35 cans, and divide it by 5 cats. Won't I also get 7? So basically what they're saying is, let me grab my laser pointer. I can take this number and divide it by that and get 7. I can take this number, divide it by that, and get 7. I can take this number, divide it by that, and get 7. That's called a proportional relationship. Okay? So where it says explain, we're going to say yes. The ratio shows that the that the table is equivalent to 7 to 1. So there is a proportional relationship between the number of cats and the number of cans. Okay, so I said yes, the table shows the proportional relationship of 7 cans to 1 cat. And because of that unit rate, I can go find how many 10,000 cats would need. I would just need to multiply it by 7. All right, next page. Ramona makes catnip toys for the cats at the shelter. She puts the same amount of catnip in each toy. Ramona makes 4 toys with 12 grams of catnip. Okay, so for every 4 toys, it takes us 12 grams of catnip. Complete the equivalent ratio table to show how many toys Ramona can make with different amounts of catnip. Luckily, they already filled out this one for us. That's what they gave us. That's the information they literally just said, right? For every 4 toys, you could do 12 grams. Okay, so now let's see. What would that mean for 3 or 1? Here's what we need to do. We need to find the unit rate. And we learned this in our last chapter. To find the unit rate, we need to divide both of these by something. I see that they both go into 4 nicely, which would give me 1 toy to every 3 grams. Okay? Did I get a unit rate? Yes. Did I find that unit rate while also filling out this chart? Yeah. For every 1 toy, it's going to be 3 grams of catnip. Now that I know the unit rate, what that means is I can say for every 1 toy that takes 3 grams. For every 2 toy that would take 6 grams. For every 3 toy that would take 9 grams. Do you guys see what I'm doing? Is I'm taking the number that's not a 1, which in this case is a 3, and I am multiplying it by each of these. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is 15. Okay, so I'm going to take the unit rate that I found, 3 grams, multiply it by the number of toys, and I can keep going. Could I then go find how much catnip 60 toys would take? Yeah, I'm just going to take 60 and times it by 3 and get 180. Okay, so unit rates, now that we've learned how to find them, are super helpful because now I can find any number in that proportional relationship. Okay? Okay. Describe the relationship between the number of grams of catnip and the number of toys. Alright, so I'm going to describe the relationship based on the unit rate that we found. I'm going to say there is 3 grams of catnip for every 1 toy. What is the unit rate? Well, we just found the unit rate. The unit rate is 1 toy to 3 grams. How can Ramona find the number of grams of catnip if she needs to make a certain number of toys? Which is what we did up here, right? If I said there's 60 toys, how much catnip would that take? You take the unit rate and you multiply it by that unknown number. I'm going to say x is the unknown number, okay? So it would be 3 times x. Or we can write that as 3x. X is our unknown number. We could also use the like a letter that stands for it. Like we could use t. So I could say it's also 3t. But I like to use x when I can. Okay. What that means is if x equals my unknown number of toys, I can put any number in there of toys and times it by 3 and know how much catnip I need. Write an equation to show the number of grams of catnip G. Ooh, they gave us the letter they want us to use. Ramona needs to make T toys. They're giving us the letters of the variables they want us to use. They don't want us to use X. We're too big brain for them. So they want to say we take 3 times the number of toys, and that'll get us how much grams of catnip. So there's an equation. Hey, we're doing algebra now. Yay. I love algebra. Okay, number 3. The table shows the hours needed for different numbers of people to clean up after a school dance. is there a proportional relationship between the quantities at the table? You guys, the first thing I do is I just keep asking myself, to go from here to here, what happened? It looks like I just divided by 1, right? To go from, ooh, I'm going to go backwards here. Blah, blah, blah. Forget I just said that. Sorry. To go from here to here, what happened? It looks like I just divided by 1. To go from here to here, what happened? Well, it looks like I took 8 divided by 2. To go from here to here, what happened? Well, it looks like I divided by 3. And then right here from here, that looks like I divided by 12 divided by 6 is 2. Now hold up, is that a proportional relationship? Look up here. Let me erase all my markings so it makes sense. I'm going to refill that back out now too. 1, 2, 3. Okay. 3, 6, 9, 12, 15. Okay. To get from here to here, what did I do? Well, I just, or I guess I could say, how did I get from here to here? I times it by 3. How did I get from here to here? I times it by 3. From here to here, I times it by 3. From here to here, I times it by 3. From here to here, I times it by 3. Now you guys, what do you notice about this table compared to this table? Are these guys the same numbers like these ones were? No, they are not. So if each of these does not get divided or multiplied by the same number nicely, then it's not a proportional relationship, okay? They have to all be the same thing. So for example, let me erase this. To get from here to here, they multiplied by 6. To get from here to here, they multiplied by 3. From here to here, they multiplied by 2. From here to here, they multiplied by 1. I see a pattern, but that is not a proportional relationship. A proportional relationship would be like if they all were multiplied by 6 to get their numbers, okay? So is this a proportional relationship? No. Why is it not? Because the ratios are not equivalent. E-Q-U-I-V-A-L-E-N-T. See, I'm not an English teacher. I don't know how to spell. Okay. These ratios are equivalent because it's 3, 3, 3, 3, 3. These ratios are not equivalent because it's 6, 3, 2, 1. Alright guys, that is the end of the lesson. We will do pages 51 and 52 in class tomorrow. Your job is to scan page 50 and turn it in. So the cat page, meow, that's the page you need to scan. Alright, bye guys.